Hi, welcome to product review by watthour. In this video we are going to do the review of this TEC-06 16 watt 3.5 ampere battery capacity tester and discharger. So this can discharge your battery and will tell you how much capacity your battery holds. We're going to fully test it and explain everything. Let's get started with this. And then we have nominal voltage. Go to the next setting, and here, once the discharge ended, I purchased this from AliExpress, and this is around $12 US plus $6 shipping. This is a 16 watt version. I'll provide you the link. So this is a device that you can connect your battery and discharge it and check the actual capacity. As we use lithium battery or any battery that you have, as the time passes, the capacity will be reduced. So when, for example, this is 3200 milliampere hour, after few charge and discharges, this will not be able to hold the same capacity. So the capacity is reduced slowly because it will not be able to hold that much charge. To check that, we need a device, and this is one of the way to do it. So this can go up to 16 watts. When we say 16 watts, it means that the voltage and current that you're testing through the battery must not exceed 16 watts. So this will adjust the current automatically, but the maximum current that you can set is 3.5 ampere, and the maximum voltage is 60 volts. Very simple. We will set our cutoff voltage, we will set our discharge cutoff voltage, and we will set amount of current at the rate that you want to discharge. For example, you want to discharge at 1 ampere, you will just set it, or maybe 2 ampere, because some batteries will get damaged if you go beyond certain rate. So you have to be mindful of that. This will allow you. So we can set two important parameters here. One is the cutoff discharge voltage, and the other one is the current that the rate of current that you want to discharge. And that's it, nothing else. The rest is just for information. So this on the screen, it shows the capacity that it has discharged, ampere hour, for example. And if I rotate it, it goes to the next one. It shows the voltage of the device that is connected to this. Length of the board is 86.6 millimeters by 58.4 millimeters. If you consider the nut, is 30.3 millimeters. When we are dealing with lithium polymer or lithium iron phosphate, there are certain important parameters in regards to voltages that we have to understand and pay attention. For example, the maximum charge voltage is the most important voltage for the battery, because if you go, for example, for lithium polymer above 4.2 volts, and for this model for lithium iron phosphate 3.65 volts, then the battery will be damaged permanently. So also these values might vary a little from manufacturer to manufacturer, but these are general values, so we should never go above these values. And then we have nominal voltage. Nominal voltage is the voltage that we mention and use it. For example, lithium polymer is called 3.7 volt battery, and one cell of lithium iron phosphate is called 3.2 volts. So this is the nominal voltage, and the most important value that when you use it or calculate the power or anything, that is the voltage that you use, not the charge voltage. And then we have discharge cutoff voltage or minimum discharge voltage. What it means is that lithium polymer can be drained or discharged until the voltage is up to 3.2 volts. If we go beyond this value, you might damage the battery permanently. And the same way for lithium iron phosphate, For this model, the manufacturer says 2 volts. So if you go beyond 2 volts, it will be damaged permanently. So we are concerned only with these 2 values when you are charging and discharging: maximum charge voltage and discharge cutoff voltage, or minimum discharge voltage. So that's the cutoff or minimum. So we have to set this properly in order to protect the battery when you're charging and discharging. Let me now explain this hardware. This is the main power. This device needs power to operate. So we will connect it via this port to power this up. Once you power it up, this cannot do anything until you connect your battery. We have these 4 ports. These 2 will go directly to your battery, and these 2 goes to the voltage. Because I'm using very thick wire, this is a 12 gauge wire, I've connected positive to the positive and negative to the negative, so we can read the voltage here. If this wire is very narrow and you think there is a voltage drop, then connect this directly to the battery with a very simple wire. This is a rotary encoder, which when you move it, it just goes by each step. It just rotates 360, but it has also a push button. And then we have these 5 LED status. Some of them are very intuitive. You can see the first light is ampere hour, that's the capacity. And here, this is milliampere in terms of current, and that's the milliohm. Let's see the other 2. Let's see. The first one, as you can see, is capacity. The second one is measured voltage. Then the third one is cutoff voltage. Now let me power it up. This is micro USB. Do not connect this to computer because this needs a lot of power and your computer might get damaged or it will shut off automatically. Protect it. So use actual wall charger. So let me explain the operation of this. Once you connect the power from external USB from a wall charger with at least 2 ampere hour, with at least 2 ampere power, then this will turn on. Now my battery is connected, not connected yet, it's just powering up, and that is showing ampere hour or capacity that have been drained from your battery. When I rotate this, it shows the measured voltage. If I connect it to my battery, you will see it shows the voltage, and if I rotate this to the next one, it shows the cutoff voltage, the discharge cutoff voltage, whatever value you want. And if I rotate it again, this is the current that you are discharging, the amount of current that you want to discharge. So this is the most important one for you to set, so you can set the rate of discharge with this. And then the last one is the internal resistance of the battery that is measured based on the parameters that we set or the battery is connected. Now, if I rotate it, it just goes back and forth. Now I have disconnected it. If I press it, it will not do anything. But in here, because we can set the cutoff voltage, if I press it, it blinks and it allows you to set the voltage. Based on the type of battery that you have, you can set it, which I've just explained. In our case, it's 8 volts. To exit back, just press it, it will exit. So the blinking was helping you to know. The next one is the amount of current that you can set. In here, we can press this, and because these are smaller value, this is 200 milliampere and higher, so we are unable to set. So you see, this is 1 ampere, 1000 milliampere, 900, 800, 700, 6, 5, 4, 450, 4, 353, 200. So we can set minimum of 50 milliampere to discharge a battery, but not less than that. Now let's go up, 6, 7, 8, 9, and that's 1000, 1100, 1002, 1003, 1004, 5, 6, 7, 8, 9, 2 ampere to, that's 2.1, 2.2, 2.3, 2.4, 2.5, 6, 3, 1500. So that is 3500 that we can do, but this will be determined by the voltage that you connected. Now let me connect my voltage. As soon as I connected the voltage, it will not allow you to drain more than 1100. The reason for that is now 13 volts battery, 13 times 1.1, so it is around 14 watts. And hours, when you're discharging, you cannot go beyond 16 watt. So 16 watt is just a relative value, so you can go higher and higher. Let me show you now. So now this is the voltage. The power is now not connected. Now I've connected 3 cell, and in 3 cell, let's go and let's set the current. You can see now we can go higher. So 1600, 1600. That's the maximum that we can set with 3 cell. So 3 cell, that's 3 cell. Let me change it. Now it's 2 cell, 6.6 volts. Now let's go and let's set the current. 2200 milliampere. So 2.2 ampere, we can set it here. 2.3, 2.4. So 2.4. So we can set 2.4 or 2400 milliampere when you have two cell lithium iron phosphate. Let's go to 1 cell. Now it's 1 cell, that's a nominal voltage. Let's go. Now let's go to the maximum and see. So 3 ampere. So 3.5 is the maximum, and it is allowing 3.5 because the total value of 3.2 volts times 3.5 is still less than 16 watts, so that's why we are allowed. Now to discharge, after setting the value, you press this to exit and then go back to the capacity. When you are here, just press it and it will start. Okay, it did not work. For 1 cell, we have to set it to 2 volts, otherwise it will not work. So now let me go to the cutoff, discharge cutoff voltage. Two volts, press it, it's done. Go back to ampere hour and press it. It will start in a few seconds. As you can see, we are just discharging it at 3.5 ampere. Exit at any moment. This is now 100 milliampere hour have been drained. To exit, just press this and it will turn off and then you exit. Now I have connected 2 cells. Let me show you the voltage, 6.5, and let's set the voltage for the cutoff voltage, 2 volts, 4 volts for 2 cell. So I'm here now. 4 volts, and here the capacity now does not allow me to go more than 2.4. So exiting, coming here. Now to reset before calculating the capacity, otherwise it will continue with this value. Just hold it for longer period, it will be resetted, and then press it. So the voltage, this is the capacity, just go, it shows 6.58, and go to the next setting, it shows 4 volts. So this will drain it until it is 4 volts, and that's the current, and that's the resistance. Now let me discharge this one. This is a NCR 18650. Here is a data sheet for the battery, and nominal voltage is 3.6 volts. All of the specification is shown. Maximum charge voltage is 4.2 volts. So the cutoff voltage is 2.5 volts. And this model has the capacity of 3200 milliampere hour. I have connected these alligator clips. Let me connect positive to positive and negative to negative. Let me show you the voltage. It shows 4.14. This is now showing 414, so that's 140 volts, that's 150, and so this much is a discrepancy, about 10 millivolts, which is not that critical, but to know. Let's set this to the maximum. Let me go down the discharge voltage 2.5, press it and set it to 2.5, exit, go to the next one. Let's drain it with certain current. Planning to see what we can do. Let's see what we can do, the maximum. So 3.5. Let's go with the 3.5 that this can do. Set it, go here and press. Now it started. So we can see the capacity. Let's move from capacity to the voltage. Already the voltage shows lower. 2.5. The temperature, how hot this is. It's 45 degrees Celsius. Let's have a look at the back, because 43 degrees. My finger here, you will see that this spot is here. This spot is 57, 68 degrees. And here, once the discharge ended, it's blinking, so 2.34 or 2.4 ampere hour have been drained from this battery, because the voltage we said the minimum was, the cutoff voltage was 2.5, so that's stopped. Right now this voltage shows higher. The reason for that is after a few seconds the voltage slowly goes up. So that's the capacity that we got. For conclusion, I would say that this device worth purchasing because it does what it claims, and the power and current will be adjusted automatically, so you cannot make mistake to burn it or make it bad. That's also another plus, and everything works as intended. So I have no affiliation with them. If you want to purchase it, there is affiliation link below this video. You can purchase it from any store. I also get some commission from that. Please thumb up the video and also subscribe. I appreciate it. If you have comment or question, post it below this video. Thank you.